go.
Hi guys! In this video, we will explore four important topics in integral calculus: the logarithmic integration, trigonometric transformation, inverse trigonometric integration, and integration by parts. I'll walk you through key concepts and demonstrate problem-solving techniques from easy to challenging examples. So, let's get started!
Before we proceed to our examples, I want you to know first what is logarithmic, its formula and how and when we will gonna use logarithmic integration. So logarithmic integration is a method used in calculus to integrate rational functions where the denominator is the function and the numerator is the derivative of the denominator. When you see a functions like du over u, proceed immediately in logarithmic integration.
So now let's proceed to our examples. So our first example is find the integral of x squared over x cubed plus 4 dx. So in first glance, it looks like tricky. But if we get the derivative of our denominator, which is the x cubed plus 4, we get 3x squared. So the derivative of our denominator is quite similar to our numerator. In this, we can assume that this problem can be solved using logarithmic integration. So for this numerator to become the derivative of our denominator, we will multiply this numerator by 3 and by 1/3 for it to become legal. So this is now the derivative of our denominator. So now we can use the formula of logarithmic, which is the ln of u plus c. So let's just plug in, copy the constant, ln of u, our u is x cubed plus 4 plus c. So this is now our final answer. So let's answer more examples. So our second example is the integral of sine 2t over 4 minus 3 cos 2t dt. So if we see this problem, we take a look at the denominator. If its derivative is in the numerator, we will assume that this can be solved using logarithmic integration. So in this case, the derivative of cos 2t is negative sine 2t. So it's perfect for logarithmic integration. So let u is equals to 4 minus 3 cos 2t. Our du will be 6 sine 2t. So this our derivative is quite similar to our numerator. So for this numerator to become the derivative of the denominator, we will just multiply it by 6 and 1/6 for it to be legal. So this is now our derivative. So let's now plug in the formula. So copy the constant, 1 over 6 ln of u, which is the 4 minus 3 cos 2t plus c. So this is now our final answer. Our third example is the integral of sine 2x over 1 minus sine squared x dx. So we all know that sine 2x is equals to 2 sine x cos x, and 1 minus sine squared x is equals to cos squared x. So our equation now will become integral of 2 sine x cos x over cos squared x. So let's separate this. So this will become 2 sine x multiplied by cos x over cos squared x. So integral of 2 sine x multiplied by 1 minus cos x. Why? Because cos x over cos squared x is 1 minus cos x. And this will become 2 integral of tan x dx. Why? Because if we multiply this, 2 sine x multiplied by 1 over cos x, it will become 2 sine x over cos x. And we all know that sine x over cos x is tan x. So, integral of 2 tan x dx is 2 ln sec x plus c. And it also be negative 2 ln cosine x plus c. So this is now the answer. Either of these two is correct. Our next example is the integral of secant squared 3u du over 1 plus tan 3u. So, let v is equals to 1 plus tan 3u. Our dv will be 3 secant squared 3u. So, our derivative is quite similar to our numerator. So, it's logarithmic integration. So, for this numerator to become the derivative of the denominator, we will multiply it by 3 and also 1/3. So, let's now plug in our formula, copy the 1/3, ln our v, which is the 1 plus tan 3u plus c. So this is now our final answer. So our last example in logarithmic integration is the derivative of x plus 6 over x plus 2 squared dx. So if we let u is equals to x plus 2, our derivative will be 1. So it's very far enough from our numerator. So instead of getting the derivative, we will get it in terms of x. So x equals to u minus 2. So now let's substitute it. So it will become integral of u minus 2 plus 6 over u minus 2 plus 2 squared. So let's simplify. So this will become the integral of u plus 4 over u squared. So since it is separated by addition, we will integrate it by parts. So this will become integral of u over u squared plus integral of 4 over u squared. So let's first integrate this u over u squared. So let u is equals to u squared. Our du will be 2u. So now let's integrate this 4 over u squared. So this is power formula. So this will become integral of 4u raised to negative 2 du. So 4u raised to negative 1 over negative 1. So our final answer will be 1/2 ln of x plus 2 minus 4 over x plus 2 plus c. So this is now our final answer.
Trigonometric transformation is the process of rewriting trigonometric expressions using identities to simplify integration. These transformations help reduce powers or convert products into sums, making integration possible. So we have here our K identities to help us simplify integrals involving powers and to convert difficult trigonometric products into sum using these identities.
So our first example in trigonometric transformation is integral of cos squared x dx. So the cos squared x can be equal to 1 plus cos 2x over 2. So this will become integral of 1 plus cos 2x over 2. So we will be putting outside the constant. So this will become 1/2 integral of 1 plus cosine 2x dx. So since it is separated by addition, we will integrate it by parts. So 1/2 integral of dx plus 1/2 integral of cosine 2x dx. So the answer will be 1/2 x plus the integral of cos 2x is sine 2x over 4 plus c. So this is now the answer. So our next example is the integral of sine cube x dx. So we all know that if we had a odd exponent, we will separate it by one odd exponent and one even exponent. So this will become integral of sine x multiplied by sine squared x. And we all know that sine squared x is equals to 1 minus cosine squared x dx. So we let u is equals to cosine x, du will be negative sine x. So this will become negative integral of 1 minus u squared. Since it is separated by subtraction, we will integrate it by parts. So negative integral of du plus integral of u squared du. So integral of negative du is negative u plus integral of u squared du is u cubed over 3. So let's substitute our u, which is the cos x. So our answer will be negative cos x plus cos cube x over 3 plus c. So this is now our final answer. So our third example is the integral of 1 plus cosine 2y over 1 minus cosine 2y dy. So we know that 1 plus cos 2y is equals to 2 cos squared y, and 1 minus cos 2y is equals to 2 sine squared y. So this will become integral of 2 cosine squared y over 2 sine squared y. So let's cancel the 2. So this will become integral of cotangent squared y. Why? Because cos over sine is cotangent. So we also know that cotangent squared y is also equal to cosecant squared y minus 1. So since it is separated by subtraction, we will integrate it by parts. So integral of cosecant squared y dy minus integral of dy. So the integral of cosecant squared y is negative cotangent y, and the integral of dy is y. So, our final answer is negative cotangent y minus y plus c. So, our fourth example in trigonometric transformation is the integral of cos cube y sine cube 2y dy. And we all know that sine 2y is equals to 2 sine y cos y. So, this will become integral of cos cube y multiplied by 2 sine y cos y cube dy. So, we will distribute the exponents. So, this will become integral of cos cube y multiplied by 8 sine cube y cos cube y dy. So, we will combine the cos cube y and cos cube y. And we will put the constant outside. So it will become 8 integral of cos 6y sine cube y. And we have a odd exponent. So we will be separating this. So this will become 8 integral of cos 6y sine squared y sine y dy. And we all know that sine 2y is equals to 1 minus cos 2y. So this will become 8 integral of cos 6y multiplied by 1 minus cos squared y sine y dy. So we will distributed or multiplied the cos 6y by 1 minus cos squared y. So this will become 8 integral of cos 6y minus cos 8y sine y. So let u is equals to cos y. Our du will be negative sine y. So this will become, we will just multiply negative 1 in the left and negative y in the right. So this will become negative 8 cos 6y minus cos 8y. So this, we can solve this using the power formula. So this will become negative 8 over 7 cos 7y plus 8 over 9 cosine raised to 9y plus c. So this is now the final answer. So our last example in trigonometric transformation is integral of cosecant raised to 4y cotangent cube y dy. So we have odd exponents, so we will separate it. So this will become cosecant raised to 4y cotangent squared y cotangent y dy. So we all know that cotangent squared y is equals to cosecant squared y minus 1. So this will become integral of cosecant 4y multiplied by cosecant squared y minus 1 cot y dy. So we will just distribute this cosecant 4y into cosecant squared y minus 1. So this will become integral of cosecant 6y minus cosecant 4y cotangent y dy. So we let u is equals to cosecant y, and our du will be negative cosecant y cotangent y. So how can we transform this cotangent y into negative cosecant y cot y? So first we will separate this, since it is separated by subtraction. So integral of cosecant 6y cotangent y dy minus integral of cosecant 4y cotangent y dy. So to have this derivative, we will be taking away 1 cosecant. So this will become cosecant 5y cosecant y cot y dy. minus cosecant raised to 3y cosecant y cot y dy. So now we have the derivative. So we will now use power formula. So our answer will be negative cosecant raised to 6y over 6 plus cosecant 4y over 4 plus c. So this is now our final answer.
Inverse trigonometric integration involves evaluating integrals that result in functions. So we have two K formulas. Integral of dx over square root of 1 minus x squared is equals to arcsine x over a plus c. And integral of dx over 1 plus x squared is equals to 1 over a arctan x over a plus c. So this helps to solve integrals involving square roots or rational expressions.
Our first example in inverse trigonometric integration is the integral of dx over square root of 9 minus 4x squared. So in first look, we all know that this is arcsine. So we will be transforming this square root of 9 minus 4x squared into a squared minus x squared. So this will become the integral of dx over square root of 3 squared minus 2x squared. So we let u is equals to 2x. Our du is 2dx. dx is equals to du over 2. So this will become 1/2 integral of 1 over square root of 3 squared minus 2x squared. So our answer will be 1 squared arcsine 2x over 3 plus c. Our next example is the integral of dx over 9x squared plus 6x plus 5. If we see this, we know that this is arctan. So we should make this 9x squared plus 6x plus 5 into x squared plus a squared. So we will get the perfect square of this. So this will become integral of dx over 3x plus 1 squared plus 2 squared. So let u is equals to 3x plus 1 over du is equals to 3 dx, and our dx is equals to du over 3. So this will become 1 over 3x plus 1 squared plus 2 squared multiplied by du over 3. So this will become 1/3 integral of 1 over 3x plus 1 squared plus 2 squared. So we just now use our formula. Let's plug in. 1/3 multiplied by 1/2 arctan 3x plus 1 over 2 plus c. So this will become 1 over 6 arctan 3x plus 1 over 2 plus c. So this is now the final answer. Next is the integral of secant squared theta over square root of 5 minus secant squared theta d theta. So we let u is equals to tan theta. Our du will be secant squared theta. So we know that secant squared theta can also be equal to 1 plus tan 2 theta. So this will become 1 plus u squared, since our u is tangent. So our 5 minus secant 2 theta will also become 5 minus 1 plus u squared. So simplifying, this will become 4 plus u squared. So this will become integral of 1 over square root of 4 plus u squared du. So we will be transforming this into a squared plus x squared. So this will become integral of 1 over square root of 2 squared plus u squared. So we will just plug in our formula. So our answer will be arc sine tan theta over 2 plus c. So this is now the final answer. Our fourth example is the integral of 3x minus 2 over x squared plus 2x plus 17. So we will make this a perfect square. So this will become integral of 3x minus 2 over x plus 1 squared plus 16. The derivative of x plus 1 is 1. So it's far enough from our numerator. Even if we get the derivative of x squared plus 2x plus 17, it's very far enough. So what we will do, we will manipulate our numerator. So we will add something to this. So we will add 3, but we will also subtract 3 for it to be acceptable. So 3x minus 2 plus 3 minus 3. So we will just rearranging it. So 3x plus 3 minus 2 minus 3. So 3x plus 3 minus 5. So we will factor out the 3. X plus 1 minus 5. So it's now look like the denominator. So now this will become the integral of 3 multiplied by x plus 1 minus 5 over x plus 1 squared plus 16. So since it is separated by subtraction, we will be integrated it by parts. So 3 multiplied by x plus 1 dx over x plus 1 squared plus 16. So this will become 3 integral of x plus 1 over x squared plus 2x plus 17 minus 5 integral of dx over x plus 1 squared plus 16. So we will first integrate this one. So this will become let u is equals to x squared plus 2x plus 17. Our du will be 2x plus 2. So it's now very similar to our numerator. So we will multiply the numerator by 2 and 1/2. So this will become 3 squared ln x squared plus 2x plus 17. So now we will integrate the 5 integral of dx over x plus 1 squared plus 16. So we will just, so we know that this is arctan, so we will just input the formula. So 5 over 4 arctan x plus 1 over 4. So our final answer will be 3 over 2 ln x squared plus 2x plus 17 minus 5 over 4 arctan x plus 1 over 4 plus c. So this is now our final answer. So our last example in inverse trigonometric integration is the integral of sine x multiplied by cos x plus 4 over 1 plus cosine squared x dx. So we will distribute the sine x into the cosine x plus 4. So this will become the integral of sine x, cosine x plus 4 sine x over 1 plus cos squared x dx. So since it is separated by addition, this will become integral of sine x cos x over 1 plus cosine squared x plus integral of 4 sine x over 1 plus cosine squared x. So we will first integrate this one. So let u is equals to cos x. Our du is negative sine x. So this will become negative integral of u over 1 plus u squared du. So the derivative of 1 plus u squared is 2u. So we will just multiply 2 on our numerator and negative 1/2 for it to be legal. So this will become negative 1/2 ln of cosine x. So next we will integrate the 4 sine x over 1 plus cosine squared x. So we will just put the constant outside, so it will become 4 integral of 1 over 1 plus u squared. So we can see that this is an arctan. So we will just now plug in the formula. So negative 4 arctan, our u is cos over 1. So our final answer is negative 1/2 ln cosine x minus 4 arctan cosine x plus c. So this is now our final answer.
Integral by parts is a technique based on the product rule of differentiation used to integrate the product of two functions. So our K formula is integral of u dv is equals to uv minus integral of v du. So you will use this when you are integrating products of algebraic and transcendental functions like x ln x sine x, and when you integrating trigonometric and logarithmic functions, and also situations where simplifying through repeated parts is helpful. We will not forget our acronym LIATE, which stands for L logarithmic, I inverse trigonometric, A algebraic, T trigonometric, and E exponential. So this helps you to choose for your U and dV. The rule here, who comes first in the acronym LIATE, will be your U.
So our first example in integration by parts is the integral of ln x dx. So let's remember our formula, which is the integral of u dv is equals to uv minus integral of v du. Let's also not forget the acronym LIATE because it is important in choosing our u and dv. So our u here will be the ln x. Why? Because logarithmic comes first in the acronym LIATE. So our du will be 1 over x, our dv will be dx, our v will be x. So now let's just substitute it in our formula. So x ln x minus integral of x multiplied by 1 minus x dx. So this integral of x times 1 over x dx is equals to integral of 1 over dx. So integral of 1 over dx is x. So the final answer will be x ln x minus x plus c. So this is now our final answer. So our second example is the integral of y cosine 4y dy. So let's not forget the acronym LIATE. So our u will be y because algebra comes before the trigonometry. So our du will be dy. Our dv is equals to cos 4y. Our v is equals to 1/4 sine 4y. So let's substitute. So y times 1/4 sine 4y minus integral of 1/4 sine 4y. So this will become y over 4 sine 4y minus, let's just take the constant outside, so it will be minus 1/4 multiplied by derivative of sine 4y, which is negative 1/4 cos 4y. So our final answer will be y over 4 sine 4y plus 1 over 16 cosine 4y. So our third example is the integral of x squared arctan x dx. So our u will be arctan x, our du will be 1 over 1 plus x squared. Our dv will become x squared and our v will x cubed over 3. So let's substitute. It will become x cubed over 3 arctan x minus the integral of x cubed over 3 multiplied by 1 over 1 plus x squared. So let's just take the constant outside. So 1/3 integral of x cubed over 1 plus x squared. So this can't be integrated, so we will manipulate the numerator. So 1/3 integral of x multiplied by x squared over 1 plus x squared is just equal to x cubed over 1 plus x squared. So this equation can't be integrated, so we will manipulate it again. So this will become 1/3 integral of x multiplied by 1 minus 1 over 1 plus x squared. So we will multiply x to 1 minus 1 over 1 plus x squared. So this will become 1/3 integral of x minus x over 1 plus x squared. So this equation now can be integrated. So we will just separate these two. So it will become 1/3 integral of x dx minus 1/3 integral of x over 1 plus x squared dx. So our final answer will be x cubed over 3 arctan x minus x squared over 6 minus 1/6 ln of 1 plus x squared plus c. So this is now our final answer. Our next example is the integral of x cubed sine x dx. So we can see that our x is in cube. That means that we will integrate 3 times. So for it to be easy, we have this method. It is called the DI method. You will be deriving and integrating. So in choosing what will you be deriving and integrating, just follow the Liate. So our D is the x cubed, our I is sine x. So the derivative of x cubed is 3x squared. The derivative of 3x squared is 6x. The derivative of 6x is 6. And the derivative of 6 is 0. So the integral of sine x is negative cos x. The integral of negative cos x is negative sine x. The integral of negative sine x is positive cos x. And the integral of cos x is positive sine x. So our sign will be positive, negative, positive, negative, positive. So we will multiply x cubed by negative cos x, 3x squared by negative sine x, 6x by cos x, negative 6 by sine x, and 0 by sine x. So x cubed multiplied by negative cos x is negative x cubed cos x. Negative 3x squared multiplied by negative sine x is positive 3x squared sine x. Positive 6x multiplied by positive cos x is positive 6x cos x. Negative 6 multiplied by sine x is negative 6 sine x. And the integral of 0 sine x is 0. So we will not be putting that here. So we will just put plus c. So this is now our final answer. So it's very easy, right? So our last example in integration by parts is the integral of y raised to 4 e raised to negative y dy. So we can see that our y is raised to 4. So it means that we will integrate 4 times. But we know that we have much easier method, which is the DI method. So our D will be y raised to 4. So the derivative of y raised to 4 is 4y cubed. The derivative of 4y cubed is 12y squared. The derivative of 12y squared is 24y. The derivative of 24y is 24. And the derivative of 24 is 0. For our I is e raised to negative y. The integral of e raised to negative y is negative e raised to negative y. The integral of negative e raised to negative y is e raised to negative y, and so on. So we know that the sign here is positive, negative, positive, negative, positive, and negative. So we will multiply y raised to 4 by e, negative e raised to negative y, and so on. So y raised to 4 multiplied by negative e raised to negative y is negative y raised to 4 e negative y. Negative 4y cubed multiplied by positive e raised to negative y is negative 4y cubed e raised to negative y. 12y squared multiplied by negative e raised to negative y is negative 12y squared e negative y. Negative 24 multiplied by positive e raised to negative I will be negative 24y e raised to negative y. Positive 24 multiplied by negative e raised to negative y is negative 24 e raised to negative y. So the integral of 0 negative e raised to negative y is 0. So we will not putting it here. So we will just put plus c. So this is now our final answer.